Good morning, friends. Today we'll start with one more problem. This is two blocks which are tied by a string, and passes through a frictionless pulley at the apex point of the uh, planes. Now, 100 Newton force is on left side and 50 Newton force is on the right side block. They are tied by a string. Now, if you leave them free, because of the 100 Newton block, which on this side is the 60 degree, is the slope uh, to the horizontal, and right side it is 30 degree to the slope to the horizontal. Because of that, it 100 Newton force block starts moving downward. As it is connected to the 50 Newton block, that also starts moving upward. So both blocks will move with the uniform acceleration and velocity. Now we are required to determine what is the acceleration of these blocks and also what is the tension in the string. So both are under dynamic equilibrium when you free them, and it starts moving on its own in the downward directions by 100 Newton block. Now you have to draw first of all free body diagram for each block. Okay, for 100 Newton block you can see here the free body diagram where the weight is acting vertically downwards, and as the block moves downwards, the string tension in the string is in the upward direction tension, and frictional force is also in the upward direction. As block is moving downwards, the inertia force MA, that is 100 upon 9.81 into A, that also moves in the direction is in the upward directions. So as the block moving down, except 100 Newton force, component of the 100 Newton force will be acting in the downward directions. So for that we will write in a, first of all we will work out the normal reaction N, and then frictional force F. Then we will write a equation for dynamic equilibrium for this block. So as 100 Newton component force perpendicular to the plane, you will get this one 100 cos 60. So that should be a sum of all forces perpendicular to the plane equate to 0. You will get N1 is equal to 100 cos 60, and that is equal to 50 Newton. So from this we will get one coefficient of friction is 1/3 multiplied by mu into N, that is 1/3 into 50, that gives 16.67 Newton is the frictional force which opposes the motion. Now here you equate all forces parallel to the plane. So therefore tension is in the upward directions, that is taken positive, and 100 upon 9.81 into A, that is MA, that is also in the upward direction, that is also positive, and only weight component 100 sin 60 is acting in the downward direction, that is minus. Frictional force is also opposing, that is plus, F1 is equal to 0. So from this we will get an equation, that is T plus 100 upon 9.81 A is equal to 69.93. This is the one equation you will get it. Similarly, for the second block of 50 Newton block, first of all we will work out the normal reaction. The fluid diagram is shown here, that is tension in the string is in the upward direction because always the cables will be under tension, and as it pulls the block 50 Newton in the upward direction, it is moving up, therefore the frictional force is opposite to that, is moving direction is downward side. Inertia force is also opposing the motion in the upward direction, that is also in MA is 50 upon 9.81 into A, that is also downward direction, and this 50 Newton weight is acting downwards, the component of that will be opposing the motion, that is 50 component of the 50 Newton. Okay. Now we'll first of all we will work out the normal reaction, and then we'll work out the this one frictional force for this. Now for consider the 50 Newton block perpendicular to the plane, you will get N2 is equal to 50 cos 30, That works out 43.3 is Newton is the uh, normal reaction. Now the frictional force F2 will get a mu into N2, that is 1/3 into 43.3, you will get 14.43 Newton. That is the frictional force. Now equate all forces parallel to the plane. 50 upon 9.81 into A plus F2, they are also opposing, the inertia force is opposing, and 50 sin 30, the weight component is also opposing. Only the tension is in the upward direction, that is minus T is equal to 0. We will get the second equation, that is 50 upon 9.81 A minus T is equal to minus 39.43. So by solving these two simultaneous equations, we will be able to determine the unknowns, that is A and T. First we will work out the A by solving these two simultaneous equations. A is equal to 1.9947 meters per second square, and substitute that value in any one of these equations. You will get tension T is equal to 49.6 Newton. That is the tension in the string. Okay. Just go through this problem. You will go for the next problem. Okay.